Hi, thanks for joining me today. My name is Ryan Swapp, and this is the Argument for Argumentative Learning. Today I hope to show how we can improve students' high school science experiences by giving them more control. This method of learning will spur social, cognitive, physical, and emotional growth in these youthful minds. In time, as results come back, we hope to convince you to support our project moving forward to hopefully eventually the state level. So why are we here? Over the course of the 2019-2020 school year, our goal is to improve students' test averages in the sciences by 5% over previous years by implementing argumentative science methods. As this PBS clip will show, science education works best when students are given the opportunity to explore for themselves.
For years, Common Core academic standards for math and English have been the subject of battles all over the country. But there's also a move afoot to set new standards for science as well, and a number of states are starting to adopt them voluntarily. Special correspondent John Telenko of Education Week reports.
It takes just 10 minutes to cross through Gillette, Wyoming. This small city sits in the northeast corner of the state, surrounded by hundreds of miles of prairie. But schools here in Campbell County are on the edge of something big, the next generation science standards.
You're going to build a strand of DNA, and you're going to decode it and figure out what that DNA actually says.
For Christy Mathis at Sage Valley Junior High School, the new standards are about learning to think like a scientist.
There's a lot of really good stuff in them. Every standard is a performance task. It's not, the child needs to memorize these things. It's the student needs to be able to do some pretty intense stuff. We're analyzing, we're critiquing, we're creating, we're actually doing the science.
Take today's lesson on genes. Mathis had her students pick fictional character cards with the name, height, hair, and eye color of each character.
This is a secret. Just you and your group know. Okay.
In teams, they built a genetic model of their characters' traits, and then the groups traded models.
And they're going to try and figure out who you had based on what you code for.
Okay, so orange, red, red represents what?
Adenine, guanine, guanine.
She has blue eyes.
Blue eyes.
That is a double.
What did you grasp about genetics from doing this exercise today?
That there are so many different parts of genetics that go into so many different things. Something as small as like the size of a gene, it's really, really small. It can change drastically how your life turns out.
Developed by the National Academy of Sciences and others, the next generation standards are more comprehensive than what teachers here had been using.
You might have had a teacher that liked a dinosaur unit and they'd turn it out in second grade, and then the same unit get taught in third grade and the fourth grade, and you're like, well, I know a lot about dinosaurs.
Before the new standards, middle school teachers like Mike Mahoney were left to fill in the gaps.
I'd always have to start at nobody knew anything at the very beginning. What is science? And it's kind of tough to get into a lot of the different curriculum things that you want to teach when you have to spend so much time just on the basics.
The new standards brought more structure, spelling out for the first time what should be taught grade by grade in elementary school.
Every fifth grader is going to have this experience. Every fourth grader is going to have this experience. Then those kids come to junior high, and it's not a catch-up game. What'd you miss? What'd you get? What do I need to do? They're always building on what came before and what comes next.
In Wyoming, Campbell County is leading the way with these standards, which the state has yet to adopt officially. 17 other states are already on board, accounting for an estimated 35% of public school students nationwide. David Evans heads the National Association of Science Teachers.
I think that the most important reason for developing new standards is that we've actually learned a lot about the way children learn. And children learn science best by actually doing it.
So far, there's been little pushback. Unlike the Common Core, there aren't yet state-level science tests to hold schools and teachers accountable, and the federal role's been different too.
The federal government and Department of Education really hasn't had anything to do with the next generation science standards. It's really just that simple. There haven't been strong incentives and there hasn't been any arm twisting.
But these new standards still have a long way to go.
There's an established line of data right now that documents the fact that we're not spending very much time teaching science in elementary school.
Nationwide, schools spend 143 minutes a day on math and reading, but only 20 minutes on science. And there's another big concern.
The majority of elementary school teachers don't feel comfortable teaching science. Most elementary school teachers don't receive a lot of preparation in science itself or in science education.
So how does the light travel?
To help its teachers, Campbell County is using a federal grant worth just under $1 million to develop new lessons for every grade. Jamie Howe teaches 4th grade.
I've learned to step back and let their exploration take over. And before, you'd always want to help them and guide them and tell them what the answer should be. So I've had to learn to step back and let them be in charge.
Nice job, guys.
We got it.
That's Gillette, a good-sized city for Wyoming. But the rest of the state looks more like this. Tons of open space and very few people. That means the schools out here are often very small, and they face a unique set of challenges in implementing next-generation science standards.
Wright Junior-Senior High School, 40 miles south of Gillette, is a good example. It has some 200 students and only 3 science teachers.
One guy teaches 7th and 8th grade, one guy teaches 9, 10, I teach 11 and 12. How'd you guys convert Celsius to Kelvins?
Small schools like Sarah Siemens can't support having specialists to teach just biology or physics. She has to do it all. How many subjects do you teach here?
I teach 4 subjects. I teach anatomy, chemistry, environmental science, and physics.
And what's that like for you?
It's challenging. Some weeks I nail the chemistry and physics and maybe environmental science, and then my anatomy class, I neglect them. What other number is going to be bigger? So then I got to do really interesting things with anatomy, and then my chemistry class kind of falls off. At least that's how I feel.
With the new standards, teachers like Siemens will have to change not in one subject, but 4.
They've just told us it's coming, that it's on its way, and be prepared because things are going to change.
Ready or not, Wyoming is on the verge of adopting the new standards statewide, but with one big exception. This is coal country, and officials removed language that had emphasized the major role of human activities, such as fossil fuel combustion, when teaching students about the causes of global warming.
Changing the standards to prevent teachers from teaching what is clearly scientifically accepted, documented information is unfortunate. But the practices of science and the way that science is done and teaching students to be able to go out and ask their own questions, collect the evidence, and know how to engage in a scientific argument is very encouraging.
Today, Wyoming has put its modified standards out for public review. They could make it to the governor's desk for approval by late fall. In Campbell County, Wyoming, I'm John Tulenko of Education Week, reporting for the PBS NewsHour.
So why does this matter to you? Arizona currently ranks 46th in preparation of high school students for college-level sciences. This remains the case even as they were number 1 in year-over-year improvements in 2016. This is happening at a time where the technology sector is booming in the state. If students are going to be successful in getting these highly competitive jobs, educators must be willing to make changes with their students in mind. As stated in the video, students are receptive to hands-on learning. The graph here shows a 1985 study at Marcos de Niza High School with their professor Hestenes, and it compares scores of a traditional physics class to modeling workshop classes. The classes using modeling and argumentative learning improved 10 to 20% more than the improvements in traditional methods classes. The classroom during this project going forward will adopt this approach, spending a majority of our classroom in the lab rather than lecturing. Students will be given vague questions and asked to design experiments to answer these questions. They will determine their procedures, their methods, what tools they'll use. When they get their data, it'll be presented on whiteboards with students critiquing other students, reducing the amount that the teacher gets involved. Students will have to formulate these concepts by themselves rather than memorizing vocabulary. So how does this help students cognitively? It exposes students to critical thinking from an early age. Students aren't going to be spitting out vocabulary from books, but they'll be better able to orally explain what is physically going on. They'll be able to look at systems as a whole, how they all work together and impact the experiment. There's also been studies that argumentative learning can help in reading comprehension, written argument, and critical thinking. Physically, there's not as much of an impact, although since we'll be in the laboratory, students will be required to be up and about a lot more often than just sitting in a lecture hall waiting for me to move on with the lecture. Socially, students will be continually working collaboratively to come up with solutions. They'll have to come to agreements before doing presentations. Otherwise, they'll go up and it won't come off as well, and they'll be asked more questions by classmates than they might otherwise get. There's going to be constant communication since they're creating all of the lab procedures and everything. They have to be in agreement on how they're going to run their lab. Emotionally, the lab groups will be together for many of the aspects of the class, giving them built-in support systems if they need help with anything. Students performing presentations are often encouraged to intentionally put mistakes in their work so that they hide their mistakes in their work when they're doing the whiteboard presentations, and other students will be looking to pick that out. This gives students who are kind of nervous about maybe being wrong incentive, because you would never know if the mistake is intentional or not. However, it's also making the rest of the class look at your work critically as opposed to just taking it at face value. Additionally, it'll just help with on-the-spot problem solving because all students will be making sure that the formulas work properly. So moving forward, this year, as I said, we'll be doing this in my classroom and another classroom at Arcadia High School, with the hopes that every year, if our numbers come back well enough, that we'll continually add more and more classrooms and hopefully have this implemented at the district level in 2 to 3 years. If we have success at the state level, that's why I'm here talking to you, because at that point, I will need your support moving forward to get this at the state level. As I said, Arizona has a booming technology sector, and our STEM areas are lacking. We must give these students the best chance to succeed moving forward. If you're interested in talking with me further about this project, I can be reached at Arcadia High School. My email address is attached. I hope to hear from you soon.